All right, this last lesson for 12.1 is going to be working on series and summation notation. There's notation that we have to help you create a series using these rules you now developed in a simple singular notation. All right, so let me read this to you, folks, so you're on to what has to happen here. When the terms of the series, in terms of the sequence are added together, the resulting expression is a series, which we've learned already. We have our finite series, which come to an end. They go from one number and go to a known end. And then there's the infinite ones that just go on and on forever and ever and ever. Discussed that earlier. Now it says we can use summation notation to write a series. For example, the two series above can be written in summation notation as follows. Now, you're going to get this new thing here called sigma notation, the Greek letter sigma. And it's a big E. There you go. That's not even that good. Let me try another one. Big E like that. And then in that, we're going to put our rule and our beginning and end points. So this here, this first example, 2 plus 4 plus 6 plus 8. We have got to account for the first number, the second number, the third number, and the fourth number. That's it. So we start at 1. So what we do is we use usually the letter I. I'll get more zoom here for you. We start at 1, so we're going to call I equals 1. We're starting at 1. And I is going to be the number that counts up for us through our iterations. And we're going all the way to 4 because we're doing it 4 times. See? 1, 2, 3, 4. And so the last number goes on top. So we're going from 1 to 4. That's what the notation means there. Now, what are we doing from 1 to 4? Well, we're going to do the rule that was developed, and we told you this rule earlier. It's just going to be 2i. So what's happening here? Well, we start again at 1. You put a 1 in for the I. 1 times 2, well, that's 2. That's your first number, right? Then you put a 2 in for I, because you're counting from the 1 down here up to the 4. So next time through, you put a 2 in. 2 times 2 is 4. And guess what? We're matching our list on the left. Next time you go to 3. 3 times 2 is 6. And then you go to 4. 4 times 2 is 8. Now you stop at 4. Why do you stop at 4? Well, you said in notation, you stop at 4. Okay. All right. So that's how you have a finite summation notation. Let's try one that's unlimited or infinite. Again, it's the same rule because it has the same numbers. So I'll do my notation with my big E. I'm starting at 1. I equals 1. My rule's the same, 2n. But this time I'm going to continue forever and ever on to infinity. And hopefully you knew that infinity is that's the infinity symbol, the sideways little 8. So you just keep going. 1 times 2, 4 times 2, 5 times 2, 6 times 2, and just keep on going and going. Okay? But again, the key takeaway for you guys is you start down here at this number and you end there. Or in this case, when it's infinite, you never end. All right, let's try some of these. It says, write the series using summation notation. Let me find one a little easier. Let's find this one first. It's a good one to start. So again, I know I'm going to have my sigma starting at 1. Now look how many numbers I got. I got 1. I got 2, 3. I got 4 numbers, but I go on forever and ever. So I know that I'm not going to have an end. So I'm going to have infinity up here. I'll go from 1 to infinity. Well, what am I doing with these numbers? Let's look at my rule. The top is going to be the actual number I'm at. I is going to start at 1. It's going to go to 2, 3, and keep counting up. So the top, my numerator, is going to be n. What's happening in the denominator? It looks like the number down here is always 1 more than the number above. So it's going to be n plus 1. So as I'm counting from my 1 up to 2, and keep going up to infinity, I'm going to put the numbers over into my rule and get my fractions. Okay? Let's try. I'm trying to find numbers I can sit here and figure out while I'm here doing this. We'll try this one out. I think I can figure this out quick enough. So again, my sigma, I'm going to call this 1, 2, and 3. Now, I don't know where it goes, but this is the last number here. It does end. It's not infinity. Even though you see these dots here, it's going to an end value. It looks to me like it's going to be 25 times 10. Because each of these numbers is times 25. 1 times 25, 2 times 25, 3 times 25. This is 10 times 25, right? Well, so then I'm going to be going from I equals 1, my first number, up to 10. Okay, and what am I doing along the way? Well, the I number, 1, 2, 3, 4, up to 10 times 25. So it's just 25I. Test it out. Put a 1 in there, you get 25. Check. Put a 2 in there, you get 50. Check. You put a 10 in there, you get 250. Check. That's how you write summation notation. So let's try a few other practice ones for you. Because then we got to go backwards. We're going to give you the summation notation and have you give us the list of numbers. All right, so here, this is 1, this is 2, this is 3, and the relationship is times 5, right? So I'm seeing a 5I all on the way. And while to get over here, this is going to be 20, isn't it? So I'm going to go 1 to 20 in my times 5 to get to those numbers. Here's my notation. Make it clear for you. So I'm going from I equals 1 to 20, and I'm going to do 5I. So 1 times 5, 2 times 5, 3 times 5, and then 20 times 5. Yeah, they all fit. Let's try this guy. I'm looking at it and I see dot, dot, dot at the end, and it's infinity. So I know I'm going to go from 1 to infinity. Oh, and by the way, we'll see it shortly, you don't always have to start at 1, okay? I'm just, it's the default, as I said at the very beginning of all this, but just be ready, you can use other numbers there. So I'm looking at this, and I'm looking at the, again, here's 1, the first, second, the third, and the fourth. So what's happening to the numbers on top? Well, they're squaring on the numerator, right? 1 squared, 2 squared, 3 squared, 4 squared. So I have I squared over here, correct? Downstairs, let's see, 2, let's see, the difference here is 3, 5. Oh, it's not even that tough. You square the number plus 1. So this is going to be 1 squared plus 1, 2 squared plus 1, 3 squared plus 1, 4 squared plus 1. So downstairs I got I squared plus 1. And there's your rule, or your summation notation. Let's look at these. This is a little trickier now. I have, looks like, well, again, here's my numbers. 1, 2, 3, 4, and it's infinity, right? So, zoom in on this for you. So I'm going from I equals 1, I think, to infinity. Looks like this is 6 for power, 6 squared, 6 to the third, 6 to the fourth. Sure. So I'm going to have 6 to the I power, because i's are going from 1 up to infinity. And the 6 is always there, being, squared or cubed, whatever. And the last one, looking at this is, looks weird, but it's actually quite simple. Watch this. So here's my summation notation. It has a beginning and an end. So, and I start, we talk about starting at 1, right? Let's say I did that. And I have 1, 2, 3, 4, well, let me show you the quickest answer and then what you may find. There's several answers to these when you're writing these rules. If I don't want to start from 1, I can start at 5. So I go right from 5. I can go right from 5 to 12, counting up by 1. And that's the simple rule right there, 5 to 12. And they just go on, adding 1 along the way. You start with 5, you go to 6, you go to 7, all the way up to 12. If you don't see that, and you want to start with 1, and that's okay, let me show you what that looks like. So again, here's your summation notation. You're going from I equals 1. But what you're doing, you're going to have to, do something to that 1 along the way. So we're basically going to add 4 to it. So it's going to be I plus 4. Okay, and then I think, so you put a 1 plus 4 is 5. Good. Go to 2. 2 plus 4 is 6. And the last number, you go from 1 all the way up. You go from 1 all the way up to 8. 8 plus 4 is 12. So these two answers that I've written here are correct. No one's better than the other, and you can always find different rules to do. But the first one here is kind of direct, isn't it? And I started at a number other than 1. All right, folks, have fun with these.